All right, here's another simple one. This one is very simple, but has a potential little trick in it that is obvious once you see it, but throws people off all the time, and so it's kind of worth running through it. So, okay, here, number 4, we have a 3-story building with no basement, slab on grade, has a column spacing of 30 by 30, and an assumed live load of 80 PSF for the floor and 30 PSF for the roof. If the dead load for both floor and roof is 20 PSF and the footing below one of the internal columns is 5 by 5, what is the bearing capacity? Like, what do we need to have in the soil? What bearing capacity do we need to have in that soil in order to make this be a safe building? And like a lot of these kinds of questions, you'll see it'll say ignore the lateral loads or ignore other things. And this is, again, this is sort of their modus operandi. Like, what they want to do is they want you to sort of strip away all the side kind of thinking that you would normally be putting into something like this and just focus on 1 or 2 small issues, just to make sure that you're capturing kind of what's going on in that sense. So here we have a little framing plan, and so we have a column spacing, we have the 30 by 30s, so there's the 30 and there's the 30, and here's the internal column, so the attributable area that's going to go to that column footing is going to be halfway between that 30 span, halfway between this 30 span, and then halfway that 30 span, and again the other side. So you're going to get a 30 by 30 in there. That's sort of obvious, but it's worth mentioning because sometimes you'll see a question like this and it seems very simple and straightforward in that same way, but then when you actually look at the way it's framed, one of these numbers will be different. So kind of the point of saying this is make sure you actually look at when they give you a framing plan, look at the framing plan, and you'll find that every once in a while it'll be set up in a way where it's not quite as simple. But generally it'll be, if you have a 30 by 30 column spacing, then the attributable area will be that same 30 by 30. So then we start looking at the loads. We mentioned that the roof load has a live load, a live load of 30 plus a dead load of 20. So therefore, that's going to be equal to 50. The floor loads have a live load of 80 plus a dead load of 20. So that's going to be equal to 100. I've obviously used numbers that add up to easy ones to calculate. 80 is not necessarily a typical number. It's not a bad number for a live load, but often it would be 100. For certain residential things, you might see it all the way down to 40 or 50. But 100 would probably be a little more typical for commercial. But this gives you just sort of an easy way to calculate. So for the roof loads, we're going to use 50. For the floor loads, we're going to use 100. So we start talking about the roof load. We've got 30 by 30. So that's going to be the area, and that's going to be times that 50. Excuse me, 50 pounds per foot. So we got pounds. Sorry, it's hard to do this with this little device. Pounds per foot. I'm probably not going to do that on the other ones because it keeps clicking me out. And you multiply that out, and that gives us 45,000 pounds. And then on the third floor, we have the same 30 by 30, and then we're going to multiply that times the 100 pounds per foot, and that's going to give us 90,000. And then on the second floor, you see where this is going. It's going to give us another 90,000. And then on the first floor, nothing. This is the little trick part that often throws people off. Because this is a slab on grade building, there is no structure at the first floor. There is no beam and column and all of that is being held up. The first floor is bearing directly onto the soil. So technically, if you want to be really technical about it, that 5 by 5 footing would actually have a little bit more load coming down directly from the floor directly above it. But in the way that the exam would think about it, it would just say, we're neglecting that, we're just going to simplify. So part of the thing here is that you understand that there's a difference between slab on grade and the structure up above. And of course, everybody would understand that as a difference, but you get sort of caught up in sort of adding the floors together, and often people will make that mistake. So we add those together, and we just get 225, I believe. And that's our total pound load coming down based on these code requirements of the 80 and the 20 and the 30 and the 20. And then we have the 5x5 footing underneath that internal column. And so that 5x5 footing is 25 square feet. So we divide that by the 25 square feet, and that's going to equal right there at 9,000 PSF. And so that is what the soil capacity is going to have to be in order to have this work. So I have to give you a little heads up here. When I actually did this, I actually wrote this as 6x6, but for some reason I had a little typo and I made it 5x5. So that's why I've just left it at 5x5 because I didn't want to send a change out and make it more complicated. And it works at D. So in this case, D is the answer. But if it was 6x6, which would be more typical, because 9,000 is actually quite a lot of PSF. And for it to be 9,000, that would really be saying that it's probably bedrock of some kind, some sort of rock. If you do it at 6x6, it comes out to about 6,000, which puts it in 7,000, which you can get 7,000 from a couple of different soil sources. So that's why it seems a little odd. It's because I actually had meant it to be 6x6. But it still works at 5x5 in terms of going through the process. So you'll find the sort of soil capacity loads, they'll range between, probably the smallest load you'll ever find on the exam would be something like maybe 1,000 or 1,500 PSF. That would be pretty not great soil and would only be really usable either in like the mat or raft like we just talked about, or in something of a fairly small scale type structure. Anything that was a bigger scale structure almost assuredly would be at least 2,000 PSF and probably 3 or even 4 or 5,000 PSF for what you'd be looking for in that soil. And if you didn't have it at a place that was easy to get to, then that's going to mean that you're probably going to reach down farther into that soil until you find it. That's why you're going to use those soil boring reports in order to figure out how far down that foundation would actually go in order to get a reasonable pounds per square foot capacity of the soil to be able to push back so that the building doesn't sink into the ground. So again, fairly simple idea, just has that one little trick on it that you have to remember that slab on grade has a different relationship to these numbers.